Have you ever wondered how a desk fan works? In this video, I will talk about how this fan physically converts energy to do work and how much energy it uses. Energy is defined as the ability to do work. Appliances in our homes, such as this fan, deliver useful energy by causing energy transformation or conversion, which is the process of changing one form of energy to another. There are many different forms of energy, such as mechanical, thermal, chemical, solar, nuclear, and electrical energy. Due to the law of conservation of energy, which states that energy cannot be created or destroyed and is always conserved, energy transformations are continuously occurring. This is the case in the example of the desk fan, which transforms electrical energy to mechanical energy in order to cause the movement of the blades and the air. The energy transformations in a desk fan. The fan is plugged into an outlet, which provides electrical energy. Electrical energy is energy that is caused by moving electrical charges. Electric charges moving in and of itself is a form of kinetic energy, and the faster the electric charges are moving, the more electrical energy they carry. So the electricity flowing into your fan is already kinetic energy because of the motion of electrons, which carries energy. When the switch is flipped to turn the fan on, electrical energy flows from the outlet to the motor, specifically to an axle or a metal rod, which rotates at the other end to provide power to drive the movement of the blades. Fans use alternating current, a type of electric current that periodically reverses direction. The motor works when the current passes through a wire in a magnetic field. The wire turns, and some of the electric energy is transformed into mechanical energy, which twists the fan blades. As the twisting fan blades are moving, they contain kinetic energy, which is converted into the kinetic energy of the surrounding air as well. The slicing of the air caused by the fan blades pushes the air, causing it to move and causing the breeze created by the desk fan. Have you ever felt like your fan or any appliance in your house heats up when that's not really its main job? This is because not all the electric energy is converted into mechanical or kinetic energy to move the blades and the air, but some of it is lost by being converted into heat energy. Some of it is even converted to sound energy. Can't you hear the sound of the blades slicing the air when your fan is working? How much energy does a fan use? In order to understand how much energy a desk fan uses, we must understand the concept of power. The power of an appliance specifies the rate at which it converts electrical energy to other forms of energy. Electric appliances are designed to work efficiently at a certain voltage, and this rating is usually written on the appliance. The voltage rating of this desk fan is 125 volts at 2.5 amps maximum. Power, which is measured in watts, can be calculated by multiplying volts times amps. Therefore, the maximum power this fan can use is 125 volts times 2.5 amps, which is 312.5 watts. This is 0.3125 kilowatts, which when multiplied by time, for example, 8 hours overnight, gives us 2.5 kilowatt hours of energy transferred in one night. To find out the cost of using this fan every night for 1 year, we can multiply 2.5 kilowatt hours times 365 days, which is 912.5 kilowatt hours. And if 1 kilowatt hour is 16 cents, it costs $146 to run this fan every night for 8 hours for 1 year. One thing we need to keep in mind about the energy used is that it depends on the power factor of the motor, which takes into account the difference between the apparent and actual wattage of the fan. Energy usage also depends on the size of the motor as well as what speed is selected. This fan has 3 speed setting options, and each one uses different amounts of energy. I hope this video was helpful in understanding how this fan or any desk fan converts energy and uses energy transformations to work